Okay, so let's continue this topic. In the previous video, we discussed the hedonic wage function, and we said that it's basically a relationship between wage and probability of injury. And the probability of injury starts with nothing, like zero probability, and then it increases all the way to 1. We discussed the indifference curves for workers and the isoprofit curves for the firms, and we said each worker have a preference. And one of the previous slides we said that, let's show it to you here. So we said that worker A, who has the steeper indifference curve, is basically a very risk averse. He or she would require a higher wage in order to be convinced to add an additional unit of injury. Okay, but worker C does not mind, so he or she has a flatter curve, right? So this one is like risk averse, and then this person is a risk taker, right? And this person is averse. So this risk averse person would need a higher increase in wages in order to be convinced to take the job, or convinced to take a risky job, or to increase the probability of injury. We also discussed the ISO profits for firms, right? So firm X, Y, and Z, and each firm again has different preference in terms of wage risk combination. So for example, here some firms find it easy to provide safe environment. Some firms, they find it difficult to provide safe environment. So the idea of this function is to match the person who dislike risk with a firm that find it easy to provide risk-free environment or less risky environment, and to match the worker who is a risk taker with a firm that is difficult to provide risk-free environment or safe environment. So we're trying to match the preferences of workers versus firms. So when we look at the writing here, so labor market matches workers who dislike risk, like worker A, person who is risk averse, with firm that find it easy to provide safe environment, like firm X. So firm X is matched with person A, and the opposite is true, right? So worker who do not mind risk, like worker C, is matched with firm Z that find it difficult to provide safe environment. And each and every point of tangency between the isoprofit and the indifference curve would give us a point on the hedonic wage function, which by the end would give us a positive, right? This is a positive relationship between wage and the probability of injury. The higher the probability of injury, the higher the wage. So when we look at the policy implication as of how much is life worth, okay, so we have some studies who found positive relationship between wage and work hazards. They computed something called statistical value of life, which is the amount that workers are jointly willing to pay to reduce the likelihood that any one of them will suffer from any fatal injury on the job. Okay, so empirical evidence regarding this relationship between wage and risk is ambiguous. So we will find some papers that found like it's positive, but actually some others found it negative, and others found it insignificant, no relation at all between wage and work hazards. But any time we are talking about risk and wages, then there is a very important statistic which is called the value of life. Okay, so value of life is comparing wages, right, or annual earning in firm Y versus firm X, but each firm has different probability of fatal injury, right? So it also compares the wage gap to the risk gap. So this is the risk level at firm Y, and this is the risk level in firm X. Okay, so for example, if the difference in wages is, for example, I'm just making up any example, 52K in the wage in firm Y, but firm X would give you 50K, right? And suppose that the probability or the risk difference in the risky versus the safe job, so Y is the risky job, is 0.0002, and the probability in the safe job has to be lower because it's the probability of injury, right? So suppose it's this number. So that means the value of life would be 2000, right, over 0.0001, which would give us 20 million, right? And when you think about it, what is the 20 million here? So this basically is telling us that based on the 2000 wage difference between the risky and the safe job, and the 1 in 10,000 difference in risk, right? This is 1 in 10,000 difference in risk. So the society value or statistical life is worth 20 million. In other words, this is how much workers needs to be compensated to accept high risk of death, and providing like an insight into the monetary value placed on reducing risk. Okay, so the other policy implication, which is related to the Occupation Safety and Health Administration, which is abbreviated as OSHA, and it's charged by charged for protection and health of the American labor. So in order to make sure that they protect the health of the American labor, they have to set certain standards and regulations, and these standards with the aim on reducing risk. Okay, however, reducing risk can come at the expense of reducing utility. So, but they want to make sure that the work environment is safe in order to improve the overall welfare of the workers. So if you look at this graph here, again, it's the hedonic wage function, relationship between wage and probability of injury, right? And here what we have is a worker maximizes utility by choosing point P. So point P is the point of maximizing utility, where the worker is on indifference curve U star and isoprofit curve pi star, earning wage star W star, and with a probability of injury rho star. So this is our initial point. Now, suppose that the government prohibits from firms from offering a probability of injury higher than rho bar. So they would say, oh, this is too much risk, do not exceed rho bar. So that means in order for the firm to reach this one, right, they would have to reduce their initial isoprofit, they have to shift it down or up, that means profit is going to decrease, right? Remember we said that as you go up, profit decreases as you go up in the isoprofit curve. So in order to reach this point, then they have to shift there and get to point Q. The same thing is going to happen for the workers. Workers used to enjoy U star, but now in order to reach the new standards set by the government, they have to move down. So the U star has to reach the U bar. So that means in order to reach this intersection point between these two, right, then they would have lower utility and lower profit. Okay, so as a result, workers earn lower wage and receive less utility, and firms earns lower profit. Also, you can see the impact of OSHA regulation when workers can misperceive risk. So they are already in a certain job, but they do not perceive the amount of risk that they are facing. So here, for example, suppose that workers are earning W star, okay, and suppose that they incorrectly believe that the probability of injury is rho 0, so they think that they are here. However, in fact, that the probability of injury is here. So yes, they are earning W star, but they are actually suffering from a higher level of risk. They are not here, but they are here. Okay, so the government can protect the workers by mandating that firms do not offer a probability of injury higher than rho bar. So they would set a standard up to here, right? And if this happens, then in order to reach this point, then the U star is going to shift upwards, leading to a higher utility for the worker. So there is a higher utility from the actual level of utility, right, to a new level of utility in order to reach the standard level of rho bar. So compensating wage differential and job amenities, there are different types of amenities on the job, whether it's job security, predictability of layoffs, work schedule, work flexibility, work hours, safety, and so on. There are so many things. So we know already that good jobs are associated with low wage rates. Bad jobs, high risk, associated with high wage rate. But whether this is actually found in real life or not, the evidence is not clear. There is no clear connection between the amenities on the job and the wage differential, except for the risk of death. So if there is a certain job that has a risk of death high, then we would see a high wage rate. So these are just the examples that I mentioned about job amenity. So the layoffs and compensating differential, let me show you something here. So again, we're talking back about our indifference curves and when we had income or consumption versus hours of leisure, or you can think of it as hours of work. So the more you go this way, then you have more leisure. The more that you go this way, then you have more work. So it really doesn't matter how you think about it, they are just the same. So if we suppose that we have a worker at point P maximizing their utility by working this much H0, so they working H0 and they are earning W0, so they are working H0 and earning W0 at this line. So the alternative job offered the worker a seasonal schedule where he receives the same wage but works only H1. So a seasonal job is on the same budget line, and that means it's offering the same wage, right? But the person is working less. So the more that you go to this way, you have more leisure. We used to be here, now we are here. So moving from P to Q entails that this worker is actually enjoying more leisure time. So it's a seasonal job, but in order to reach it, then they have to decline their utility. Okay, the other option is if they want to be at the same level of utility, they need to be at point R, but in order to reach point R, then I need to see some kind of rotation in the wage rate such that we can reach point R. So in other words, the job must raise the wage to W1, right? So that the worker would be indifferent between this combination versus this combination because both of them are on the same indifference curve. And the last slide is about health benefits and compensating differential. So whenever we talk about compensating wage differential, it's not only about the wage, but it's also about types of health benefits. So we can have two workers, they face various compensation packages offered by isoprofit pi 0. So when you look at the isoprofit pi 0, this one pi 0, okay, so we see that, for example, this person prefers to have 0 health benefits and to get a high wage. Worker B, so this is the utility of worker A and it's tangent to the budget line at this point, and this is the point that this person is enjoying the combination, all wages, nothing health benefits. Another worker, worker B, prefers some combination between the two, so this much of wage versus this much of health benefits. So that means there is a trade-off, right? I can decrease this, but I can increase. So there is no way I increase health benefits without reducing wages, and the opposite is true. So there is a trade-off. But we can also find some kind of positive correlation if you look at point movement from point Q to point Q star, because you're moving this way, so it's a positive relationship between wage and health benefits. So in empirical models, the results are mixed up because some are able to find positive relationship between health benefits and wages, and others were not able to find such relationship. Alright, so I'm gonna stop here, and this is the end of chapter 5. And let me know if you have any questions.